Hi Math Knights, this is Ron Martiello and I'm here to discuss with you conceptual understanding with comparison problems. I want to let you know that I got a lot of my information from a website called Achieve the Core, and if you follow this bit.ly or if you do a search for Achieve the Core, problem types, it'll lead you to a website about all these great problem types as you analyze word problems with your kiddos. These are the problem types that you should be looking into. And now what we're going to do is we're going to do a series of videos where we match those problem types to some of the conceptual models that we should be teaching. So let's get started. So we are going to discuss what a conceptual model might look like in a comparison problem. This model is a comparison bar model and is a representation of the problem. It's not going to help students solve the problem, but it's going to set up like a blueprint for the students so that when they start working in the procedural piece or their procedural skills, they are going to be able to transfer that information and have the numbers do the work for them. But let's set this up. First, a comparison problem has a bigger number. A comparison problem also has a smaller number. And then a comparison problem also has a difference between the two numbers. And many times our younger learners in math don't understand what that difference means. They might want to attribute the difference to the smaller number or the larger number, but really it's hard for them to understand because it's the space in between the top of the bigger number and the top of the smaller number. We really have to make sure we're explicitly teaching this part to our students so that they understand we're talking about the space between the two numbers. There are some key words that go along with comparison problems. For example, more than. More than means that the bigger number is more than the smaller number. Less than. Again, the smaller number is less than the bigger number. Many times these words trick students up because they see more and they want to add. We want to explain to students that more than is a comparison and that there is a difference involved. If we use these conceptual models for comparison problems, then students should be able to identify what that difference is, whether the problem is asking them more than the smaller number or less than the bigger number. Problems will ask students for different parts of a comparison problem. Sometimes the difference is unknown. The space between the bigger number and the smaller number is what the author of the problem really wants them to find. So we have to make sure that we ask students when they read the problem, are you looking for the difference, the bigger number or the smaller number? In order to find the difference, we need to take the bigger number and subtract it by the smaller number to find the difference. In problems where the smaller number is unknown, we have to take the bigger number and subtract it by the difference. That's the space between. And again, reinforce with your students that the difference is the space between the bigger number and the smaller number. This is very important because we don't want students to attribute the difference to the smaller number because the smaller number is unknown. The third way we can look at this problem is if the bigger number is unknown. If we take the difference and the smaller number and we add them together, then we'll be able to find the bigger number. It's very important that students understand that the difference, that space between, is not the bigger number. It's a number that is unknown to us. So we have to take the smaller number and the difference, add them together in order to get the bigger number. This model has been incredibly helpful to a lot of students. The important part to this is that once we analyze the problem as a comparing problem, and we put this comparison bar model in play, that students have enough time to talk about this model. We are not to be teaching this model procedurally, like step 1, step 2, step 3. It is actually more worthwhile to have the students draw out the model, identify what number they're looking for, whether it be the bigger unknown, the smaller unknown, or the difference, and then talk about ways they can solve the problem using numbers. So there you have it, Math Knights. Conceptual understanding with comparison problems. You could utilize this video in two ways. One, you could utilize it for your own understanding and share it with your friends and talk about it at a PLC in order to improve your practice with students during math class. You can also use this as a flipped video for your students. Maybe you want to snip it down into smaller parts and give it to students via Google Slides and have students watch this video as they try to analyze comparison problems and utilize conceptual understanding. In either case, I wish you well, and I hope you have fun utilizing conceptual understanding in analyzing comparison problems. Take care.